Hello and welcome to the lecture on 6.2. Today we're going to talk about right triangle trigonometry. Let's jump right in with the definitions of sine, cosine, and tangent. And this is actually the reason that I go over these two sections before I start chapter 5. So whenever we have a triangle, a right triangle, we have a right angle here, we can label a side theta. Now, when we're looking for the sine, cosine, or tangent of this angle theta, what we're looking for is actually a ratio. Opposite theta, we have a side. We'll call this the opposite side. Adjacent to theta, but not the hypotenuse, we have the adjacent side. And the hypotenuse is always opposite the right angle. So this one is the hypotenuse. Right, now we're ready to define sine, cosine, and tangent. These are going to be ratios of each of these sides with respect to this angle. So I want you to also think about for a second, if I labeled this theta instead, this angle theta, then the opposite side would not be this side, it would be this side. And this would be the adjacent side. But because this is my angle theta, this is the angle that I labeled theta, this is the opposite side because it's across from theta, and this is the adjacent side because it's next to theta. The sine of angle theta is the ratio of the opposite side to hypotenuse. Right, what this means, when we say ratio, what I mean is we're going to define sine of theta to equal the opposite side divided by the hypotenuse. Find cosine now. The cosine of angle theta is the ratio of the adjacent side to the hypotenuse. So we would have, we're comparing this side and this side as a quotient. The cosine of theta will be the adjacent side divided by the hypotenuse. The tangent of angle theta is the ratio of the opposite side to the adjacent side. So in this case, we would have tangent of theta is equal to opposite divided by adjacent. Now these definitions are extremely important. Again, this is exactly why I cover this section here. I cover this section in the very beginning of the class because when we go back to chapter 5, we're going to use these ratios to figure out the unit circle and how we look at different values on the unit circle. And again, you'll understand more once we get back to chapter 5. So if we look at the trigonometric ratios, and let's draw this out. We're just going to write them all out very quickly here. We have, again, the opposite side, the adjacent, and the hypotenuse. Now the three trig ratios we already know. We have sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. And tangent of theta is opposite over adjacent. There's three more trig functions that we don't have labeled here. Namely, the reciprocals of each of these. We'd have cosecant, which is the reciprocal of sine, and we'll talk about reciprocals later. This is hypotenuse over opposite. You just flip this fraction. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. And these are the 6 trig ratios we're going to be dealing with the entire semester. We want to make a quick note. So suppose that we have this triangle here. Suppose that we have this right triangle. 3, 4, 5, theta. I want to make a note that the ratios do not change no matter how large the triangle becomes, as long as the angle stays the same. So for instance, if we extend this triangle, but we keep the angle the same, suppose this side is 40, this side would then be 30, and this side would be 50. Notice that the ratio is going to stay the same. The sine of theta will be 3 divided by 5 for this small triangle. Now, because the angle theta didn't change, the sine of theta for this bigger triangle should also be the same. So sine of theta, 3 over 5. And then if we talk about the bigger triangle, sine of theta is going to be 30 divided by 50, which reduces to 3 over 5. So it is actually the same. It doesn't change. The ratio doesn't change as long as the angle doesn't change. An example, find all 6 trig ratios of the triangle. So this is our triangle here. 2, 4, 2 root 3. All right. Now I'm going to label this angle theta. And we're looking for sine theta, cosine theta, tangent theta, and their reciprocals, cosecant, secant, and cotangent, respectively. Let's start with sine theta. Now, you should pause the video and see if you get the correct answers, and then come back and restart it. But sine theta should be the opposite over the hypotenuse. Again, the hypotenuse is directly across from the right angle, so in our case, the hypotenuse has length 4. The opposite side has length 2, so we get 2 divided by 4, which is, of course, 1/2. Cosine theta will be the adjacent over the hypotenuse. So our adjacent side here is 2 root 3 divided by 4, which is root 3 divided by 2. And then tangent is opposite over adjacent. Opposite side is 2, adjacent side is 2 root 3, so we have 2 divided by 2 root 3, and we get 1 divided by root 3. Opposite side divided by the adjacent side. Now, again, we know that this is the opposite side because it's across from theta. It's directly across from theta. Cosecant then will be hypotenuse over opposite, 4 divided by 2, or you could just reflect the sine fraction. So sine of theta was 1/2, which means cosecant is 2. Secant theta will be the reciprocal of cosine, so 2 divided by square root 3, which is 2 root 3 over 3, if you wanted to rationalize the denominator. And lastly, cotangent is going to be root 3 divided by 1. Now, I won't always rationalize my denominators. I personally don't care if the denominator is rationalized or not, but some instructors do. Go ahead and try one on the accompanying worksheet. Find all 6 trig ratios of the triangle. And your triangle is going to be a 3, 4, 5 triangle. The next topic I want to talk about is special triangles. Now, there's really 2 special triangles that we go through. They're going to come from a square and an equilateral triangle. We have our square here. If we draw this line slant, we get a 45-degree angle here, 45-degree angle here, and then of course our 90-degree. For an equilateral triangle, if we draw a line straight down, we would have a 60-degree angle. This entire angle is 60 degrees, which means because we split it in half, we get a 30-degree angle here, and then a 90-degree angle here. So recall the Pythagorean theorem. a squared plus b squared equals c squared. This works for right triangles, where c is your hypotenuse. If in the square we had each side was length 1, then this cross will be square root 2. We would have 1 squared is 1, plus 1 squared is 1. So we would have 2 is equal to c squared, so c is equal to the square root of 2. Now for the equilateral triangle, it's a little bit easier if we just say that each side is length 2. Then we would have this line bisects this line. So we would have 1 here and 1 here instead. Now we need to figure out what this side is. In this case, we have our a, our b, and our c. Our c is 2. So we'd have a squared plus 1 squared is equal to 2 squared. So a squared is equal to 3. B squared is 4. And then you subtract 1 over, so you have 4 minus 1 is 3. So a squared is 3, which means the a is the square root of 3. Means here we have the square root of 3. Now using the definitions of sine, cosine, and tangent, we can figure out the ratios for each of these angles, 30 degrees, 60 degrees, and 45 degrees. In degrees, we have the 30-degree angle, the 45-degree angle, the 60-degree angle. We also can figure out a 0 degree, so we'll add that in there. And then the 90 degree we can also figure out. So in radians, 0 degrees is 0 radians, 30 degrees is pi over 6 radians, 45 is pi over 4, 60 degrees is pi over 3, and 90 degrees is pi over 2. And we'll get into how to figure these out when I cover the unit circle. But for now, I'm just giving them to you. Sine of 0 degrees. Sine of 0 is actually going to be 0. Cosine of 0 is 1, and tangent of 0 is 0. 30 degrees. So sine of 30 degrees. Here's our 30-degree angle. Sine is going to be opposite over hypotenuse. Hypotenuse is 2. The side opposite 30 degrees is 1. So we have 1 divided by 2. Cosine of 30 degrees will be adjacent over hypotenuse, so root 3 over 2. And tangent of 30 degrees would be opposite over adjacent, so 1 divided by root 3. And this is one of those times where I'm not going to rationalize the denominator. I usually don't when it's tangent. Sine, cosine, and tangent of 45 degrees. So we could choose either one of these angles. They're both 45 degrees. We'll just use this one. Sine of 45 is opposite over hypotenuse. So 1 over root 2. Usually we rationalize this one and we say root 2 over 2. But 1 over root 2 is also acceptable in my book. Again, a lot of teachers don't like that. Cosine will be adjacent over hypotenuse, so 1 over square root 2, which again is root 2 over 2. And then tangent is opposite over adjacent, so 1 divided by 1 gives us 1. Cosine of 60 degrees will be opposite over hypotenuse, root 3 over 2. Cosine is adjacent over hypotenuse, 1 over 2. And tangent is opposite over adjacent, or root 3. So sine of 90 degrees is going to be 1, cosine is 0, and tangent is undefined. I do want to make a note that cosecant of theta, I've already said that it's the reciprocal of sine. The same thing as 1 divided by sine. Secant of theta is 1 over cosine. And cotangent of theta is 1 over tangent. Now I've already stated this, I never wrote it down, but I did state it. And it comes in handy when you do examples like this. Solve the right triangle. Suppose that we have a 30-degree angle, and we know the hypotenuse is 6. When we're trying to solve a triangle, we want to know what the length of each side is and what each angle is. We know this is a right angle, so we already know that this is 90 degrees. And since all angles of a triangle add up to 180, in order to get this angle alpha, we just need to subtract 90 and 30 from 180. We also need to find A and B. So we know that alpha plus 30 degrees plus 90 degrees is equal to 180 degrees, because all angles in a triangle add up to 180. Subtract 120 from the left and right, and you get alpha is equal to 60 degrees. So we know what alpha is, we're good there. We just need to figure out what A and B are. In order to find B, we just do sine of 30 degrees is equal to B divided by 6. We can do that because we know that sine of 30 is going to be the opposite over the hypotenuse. So if we multiply this 6 over, we would have B is equal to 6 times sine of 30. Sine of 30 is 1/2. So we end up with B is equal to 6 times 1/2. Now we know what B is. B is 3. We know what alpha is, 60 degrees. We just need to figure out what A is. In order to figure out what A is, we want to relate this angle, this side, and this side. So 30 degrees, the adjacent side, and the hypotenuse. So what trig function do we use? Cosine 30 will equal A divided by 6. Then we can multiply the 6 over just like we did before. 6 cosine 30 degrees is going to equal A. Then we just need to figure out what cosine of 30 degrees is. 30 degrees, cosine is root 3 over 2. So A is equal to 6 times square root 3 divided by 2. Cancel here. We get that A is equal to 3 root 3. And that's it. We've solved the triangle. We know what each side is. Alpha is 60, A is 3 root 3, and B is 3. And we know all the other angles were given. Angles and sides were given. All right, the last topic I want to talk about is the application of trigonometry of right triangles. First things first, we need to go over a couple of definitions. The line from an observer's eye to the object they are looking at is called the line of sight. So suppose that we have someone here. Maybe it's Luke Skywalker, maybe it's not. We got an X-wing up here. This line from his eye to the thing that he's looking at is called the line of sight. If the object being observed is above the horizontal, then the angle between the horizontal and the line of sight is called the angle of elevation. So let's go back to our picture. Let's say that we have the horizontal right here. This angle right here is called the angle of elevation. If the object being observed is below the horizontal, then the angle between the horizontal and the line of sight is called the angle of depression. So again, let's go back so that we have Luke Skywalker again. Here would be the horizontal. And we've got Yoda here. This is called the angle of depression because it's below the horizontal. let's go ahead and do an example. Suppose the Republic flag flies on the Senate building on Coruscant. Rex, standing 50 meters away from the base of the building, measures the angle from the ground to the line of sight of the base of the flag to be 63.4 degrees. The angle from the ground to the line of sight of the top of the flag is 65.6 degrees. Find the height of the flag. Go ahead and draw a picture really quickly here. Suppose this is our building, and then we have our flag. Rex, over here, measures, or so remember, he's standing 50 meters away. And he measures the angle to the base of the flag, be 63.4 degrees. He also measures this angle to be 65 degrees, 65.6 to be exact. We need to figure out the height of this flag. Now, it might not be immediately obvious. The mistake that you're going to make, or the mistake that you might make, is you might be looking at this triangle right here and saying, how do I figure this out? You don't want to do that. You want to look at these a little bit more broadly. We have a right triangle right here. And we have a smaller right triangle right here. So we're going to use the green and the yellow right triangles. Specifically, we want to figure out the height here of this green opposite side and the height here of this yellow opposite side, and then subtract them. Right? Now, we have this length from Rex to the building, which is 50 meters. So what we want to do is we want to relate this angle, the opposite side, and the adjacent side. Again, this angle, the opposite side, and the adjacent side. So which trig function deals with opposite and adjacent? It's going to be tangent. The tangent of 63.4 degrees will be x divided by 50, where x is the height of this yellow triangle. Multiply the 50 over. And we have 50 times the tangent of 63.4 degrees. Tangent of 63.4 is approximately 2. So x will be approximately 100 meters. Now again, that's only the height of the yellow side. Let's call this one y, so we can figure that one out. That's the height of the green side. Again, we're looking for the ratio of this angle, the height of the green, and this length of the green. The length of the green is 50. And the ratio will be opposite and adjacent. So again, it's tangent. Tangent of 65.6 degrees will equal y divided by 50. So y will equal 50 times tangent 65.6 degrees. That's going to be approximately 2.2. We have 50 times 2.2 will be about 110. So y is about 110. X is about 100. So the height of the flag is going to be roughly 10 meters tall. All right, that's going to be it for today. I will see you all in the next lecture.